Hi, A&Pers. This is Dr. Jones checking in. This is A&P II Lecture Test 5, Video 3. We're talking about BioChem. Yay! So we are on page 5, top of page 5 in the Noteset, which, if yours printed out differently than mine, starts with this bit. So I do want to point out what I have written off to the side here. Our book goes through the top circle. The citric acid cycle is actually kind of a snowman because there's a top cycle and then a bottom cycle. And then the first time the book goes through it, it discusses them separately. What happens in the top cycle, what happens in the bottom cycle. And then when we go back to do the reviews, it uses these together as one process, the whole citric acid cycle, the whole snowman as a person, snow person. Okay, so, okay, we're making red. In the mitochondrion, and I do have a Pepper the Pupper on the floor here, and I picked her up and she wanted down, and now she's staring at me and whining a little bit. So, my daughter is asleep. She's taking a nap, and so that's why I've got a Pepper. Oh, I have to tell you a story. My daughter is a genius. She took a hollow chocolate bunny and peanut butter and put peanut butter in the hollow chocolate bunny. That's a game changer. It really is. That's why they're hollow, or that's how we can make use of them being hollow anyway. So she said it was amazing. Here we go. Okay, so back to BioChem. In the mitochondrion, the pyruvate that we made in glycolysis is broken down in a process that makes one carbon dioxide, one NADH. Okay, the version of the book that I got this from, they missed the NADH here. They have the arrow, but no label. So there it is. And one 2-carbon acetyl group that temporarily binds to CoA. So here's our 2-carbon acetyl group. So we had 3 carbons, and we snapped one off to make a carbon dioxide, and we're left with 2 carbons. 1, 2, 3. See how that works? And then that binds to coenzyme A, which is CoA, and we have an acetyl CoA. So this is our little circle, and it feeds into the big circle. Okay. The function of the citric acid cycle is to remove hydrogen ions and transfer them to coenzymes. And here's our first coenzyme with hydrogen atoms attached. Okay, now let's talk about the big circle. In the big circle, and see here they've kind of glossed over the little circle. So let's talk about this big circle underneath. I know, Pepper, I'm sorry. I am here. In the mitochondrion of the cell, using no oxygen, 2 waters. Do you see where the waters go in? No, waters aren't on this picture. And 1 pyruvate. Here's our pyruvate. Come on up. She did not want up. The citric acid cycle makes 1 ATP. Here it is. 3 NADH. 1, 2, 3. 1 FADH2. That one's over here. And 2 carbon dioxide. 1, 2. So let's draw all of the important bits here on the picture. Okay, here's the whole shebang. So we have on our picture, and this picture is on the test, so it is worth your time to learn this. Now, when I learned this in biochem in chiropractic school, we had to learn the limiting enzyme at each step. Like not, oh, this is a 4-carbon molecule. We had to learn the name of the 4-carbon molecule, the name of the enzyme. Of the enzymes, the name of the enzyme that you run out of first. Luckily, we didn't have to learn the name of all the enzymes. I'm sure there are people who could tell you that. I was never one of them. Thank goodness. Thank goodness. Okay, so pyruvate. And then here we have an NAD that enters the system, and an NADH. So I'm underlining the things that for you to write in. And then draw in an arrow, because I couldn't make 2 arrows, a carbon dioxide. So that's what happens in this little circle. Pyruvate, make an NADH, a carbon dioxide, and the acetyl-CoA. And then that joins this 4 carbon. So you've got 2 carbons here and 4 carbons here, and they join to make this 6 carbon that we're going to start with, and same 6 carbon. And then you have an NADH that goes into the arrow, and what comes out is NAD goes into the arrow, NADH, and a carbon dioxide come out. So if a carbon dioxide comes out, we're going to lose a carbon. We've got 6 carbons here, and now we've got 5. And then, okay, let's come back to this. Skipping that mess, we have an FAD to an FADH2, and then we add in a water. You'll have to draw that arrow in, it wouldn't let me add that. And then an NAD to another NADH. So let's do with this down here. So this kind of feeds into itself with this coenzyme, is released and then reused throughout this process. It's the same as a coenzyme A up here. So we have a water going in between these 4 carbons, and they make a CoA. At the same time, in the same reaction right here, a GDP is turned into a GTP. And this is the same as ATP, except with a guanine instead of an adenine. And so then we're going to use this GTP, snap that 3rd phosphate off, and put it on an ADP, making an ATP. Yeah, I know. So meanwhile, this CoA goes back a step, adds to an NAD, which makes an NADH and a carbon dioxide, and the carbon dioxide is how you go from a 5 carbon to a 4 carbon. Clear as mud, right? Okay, let me hold mine up. Let's make this bigger. There we go. So this is what you're looking to draw in. There you go, ATP at the bottom. You got that? Okay. Very nice. Next. Page 6. Because the glycolysis breaks glucose down into 2 different pyruvate molecules, each glucose molecule that enters the cell causes a citric acid cycle to turn twice, 1 for each pyruvate. So, to sum up, the location of the glycolysis is in the cytosol. The main substrate, there are others, is the glucose. Main product are the 2 pyruvic acids, the 2 pyruvate. We made 2 NADH right here. We didn't make any FADH2. And the ATP yield is 2 net because we burnt 2, made 4, 2 net. Okay. Now we're going to do the citric acid cycle for 1 pyruvate and then come back and do the 2 pyruvate together, which will be per oxygen. So the citric acid cycle per pyruvate, location, of course, is the mitochondrion. Main substrate here is 1 pyruvate. Main products, 3 carbon dioxide, 4 NADH, 1 FADH2, and 1 ATP from the GTP, that little shebang we had going on down here. I'm in the way. Okay, so now, because each glucose splits into 2 pyruvate, and each pyruvate goes individually through the citric acid cycle, which is not a physical structure, it's just a process. So we're clear. Each glucose will create twice as many products. Did you catch that? Because each glucose is split into 2 pyruvate, and each pyruvate makes 1 ATP, and the glucose makes 2 pyruvate. 1 times 2 is 2. So if you take this column and double it, then you get everything that you make per glucose. So location is still the mitochondrion, but now our substrates are 2 pyruvate. We're going to make twice as much carbon dioxide, twice as much NADH, twice as much FADH2, and twice as much ATP from GTP. So 6 carbon dioxide, 8 NADH, 2 FADH2, and 2 ATP from GTP. So that's how that works. So per glucose, how many ATP do you make in the citric acid cycle? 2. Per pyruvate, how many ATP do you make in the citric acid cycle? 1. Per glucose, how many net ATP do you make in glycolysis? 2 net. So those are all test questions. Okay, now the fun part. That was the easy part. So, making ATP as a result of the transfer of electrons from the coenzymes NADH and FADH2 to oxygen by a sequence of electron carriers within mitochondria is called oxidative phosphorylation. The reaction, basic concepts, 2 hydrogen atoms, molecules, 2 hydrogen molecules plus an oxygen molecule makes 2 waters. So we've been talking about hydrogen ions, which are H+, and now we're talking about hydrogen molecules, which are H2. So that's different. The electron transport chain, it's definitely a chain now, it used to be a system, is across the inner mitochondrial membrane. It makes most 90% of the ATP, and it is aerobic. This is the aerobic part. This is the part that uses oxygen. Movement of electron releases energy that drives hydrogen ion pumps. The pumps move hydrogen from the matrix to the intermembrane space. This creates a high concentration gradient, which we mentioned briefly before. Chemiosmosis is a new word. It wasn't in the previous edition of the book. Excuse me. It's the kinetic energy of moving hydrogen ions used to make ATP. As hydrogen ions move back into the mitochondrial matrix through a hydrogen channel, ATP is generated. For each NADH from the TCA cycle, okay, the previous edition had a number here, but it doesn't give a number here, so we've got a question mark. An unknown number of hydrogen ions are pumped, but it definitely generates 2.5 ATP on its return. Yeah, I know. Excuse me. For each FADH2, question mark, making 1.5 ATP on their return? Yeah, I know. And for each NADH from glycolysis, because it passes to the FADH2, hydrogen pumps making 1.5 ATP. Okay, we got one more page, so we're going to finish this up. So to sum up, and now I got a better picture for you. At the intermembrane, so we've got, this is a close-up of the membranes of the mitochondria. We've got the cytosol, the outer membrane, and by membrane, we mean phospholipid bilayer, as always. The intermembranous space, the inner membrane, if it had folds showing, those would be cristae, and this is the matrix, which is the inside. So the citric acid cycle happens in the matrix. So from the, all right, let's keep going in the note set. At the inner membrane of the mitochondria using NADH or FADH2 and oxygen, the electron transfer system makes ATP and water. Okay, so what happens here is this NAD drops off these two hydrogens, NADH plus H plus, drops off these two hydrogens, which get pumped across into the intermembrane space. And that two, when those two come back through, they make roughly 1 ATP. Now the FADH2 drops its off at a different spot, so this helps pump more hydrogen, so that's why this makes more ATP. But if you start here in the process, like the FADH2, then we pump 2 here and 2 here, 4, and then that makes less ATP than this NADH did. But the NADH, okay, so this is the NADH from the glycolysis. The NADH from the citric acid cycle passes its hydrogens to FADH2, so it also makes less ATP. I know. BioChem's not my thing either, but it is what it is, and this, I've pared it down to just the minimum that we need, and then we're going to move on. So we'll get through it. Let's figure out the total number of ATP generated from one glucose molecule by glycolysis, the citric acid cycle, and the electron transport chain. And then here's the chart. Those used to have numbers. These used to be clearer, but it's probably more accurate IRL. Wow, that's blurry as all get out. Okay, that was scary. Let's click again, see what comes up. Okay, per glucose, glycolysis makes a net ATP. Again, it makes 4, but it burnt 2 to start the process, so 2 net. The citric acid cycle makes 2 ATP from GTP. And then the electron transfer chain, and we've got 2 times something, and this is anywhere between 3 or 5, depending. So that's where the 2 difference is. And then the 8 NAD times 2.5, because we said the NAD, FADH2, NADH from glycolysis makes 2.5 ATP. So 8 times 2.5, 20. And then 2 times 1.5 is 3, so this is 2 FADH from the citric acid cycle times 1.5 ATP per FADH from the citric acid cycle from that previous chart. Top of the same page is 3. 2 times 1.5 is 3. And then when you add this up, you get 26 to 28. So how many ATP are made per glucose in the electron transport chain? 26 to 28. And then how many ATP are made per glucose, plus 4, 30 to 32 total per glucose. Okay. So, terms that we need. So here's the whole thing summarized for you. Okay. So, glycogen is a sugar storage molecule. Glucose is your basic sugar thing. And then here we're making a pyruvate. This is the pyruvate is the next thing. Times 2. That's an X. Okay, so these terms don't come up in order. So glycogenolysis, which is the last thing on the list, breaks down the glycogen into glucose, glycogenolysis. So glycogen, which is this sugar storage molecule, lysis, which is to break down glycogen, and you're just basically popping those glucoses off that branched pop-breed structure, which is a bunch of glucoses stuck together. So when you start popping those glucoses off so you can use them, that's glycogenolysis. What's the next term that pops up? Gluconeogenesis, which we've mentioned, happens in the liver, and you make glucose. So gluco for sugar, glucose, neo for new, genesis for make, so make new sugar. Easy Latin. Gluconeogenesis. Psh. Ain't nothing to it. That was a joke. Okay. Glycogenesis. Genesis is to make, glyco for glycogen. So glycogenesis is when we store glucose as glycogen. That's when we make glycogen. Glycogenolysis breaks down the glycogen. Glycogenesis makes the glycogen. Gluconeogenesis makes glucose. And that leaves glycolysis. Glyco, and this refers to the glucose now, so I don't know why it has a Y. Glycolysis, it breaks the glucose down into pyruvate, burns to ATP, makes 4 ATP, burns to ATP, makes 4 ATP, and water, and yada yada. Okay. And then, yeah. And that, my friends, is BioChem II. Oh, the heat transfer thing. Okay, this is cool. So in a hot environment like, Texas in summer, the blood, of course, comes down the arteries, goes up the superficial veins. The superficial veins are closer to the surface of the skin, so the heat radiates off of you like a radiator, like literally, like because the heat's right up by the surface of the skin. Now, in a cold environment, I know it's Texas, don't know what I'm talking about, but I'm hang out in HEB long enough. The superficial veins shut, and all the blood goes up the deep veins, the ulnar, radial, brachial vein that run with the arteries. And so there's less heat at the surface of the skin, and that heat is deep in the center of the arm. And what happens is this heat transfer thing. There we go. Whereas the warm blood comes out, it heats the blood the cold blood from your extremities going back to the trunk. And then the cool blood returning cools this blood as it goes to the capillaries so that you're not wasting heat on extremities that can't maintain it. So it's actually a pretty cool thing. Are there two of the same slide here? That's the slide. That's the same slide but bigger. Okay, now we're done. All right, so this has been A&P II Lecture Test 5 video, I don't know, 3 probably. What did we do? How many pages did we do for video 2? I didn't write it down. Video 1, we did page 2. And video 2, we did, I think, 3 and 4. And then video 3, pages 5. Did we do 5, 6, and 7 in one video? Oh my good criminy. 5 through 7. So video 4, we will come back with page 8 and the urinary system. Thank you as always for tuning in. The education must go on. Dr. J out.